Alright, here's a little trapezoid that I want to show an example of how to find the area of a trapezoid in this type of situation. And by them telling you it's a trapezoid, of course these two sides are parallel, and that's obviously known because that's the definition of a trapezoid. Let's get into it. How do you find the area? So what we see here is this angle 103 degrees here, and we think, that's some sort of trick to unlock this problem. Well, hopefully you know the original area of a trapezoid, which is the formula is area is half times your two bases added together times the height. And the height has to be at a right angle, which we have here, but it's not labeled. And I hope you realize that yes, B1 and B2 are just the 7 and the 8. So we can put those in. And 7 plus 8 will of course be 15 in the next step. But what's really missing is this height. And I hope you see that this height could be easily seen over here, but you could also see it right here if you wanted to drop this line down, and that same height would be right here. And in fact, looking for this height right here is actually very helpful because it kind of gets right to the 103. So yes, these are the same height. Let's keep this here and let's see what we can do. We're really kind of stuck though, because what is this height? If we just knew it, we could put it in. Well, let's see what we know. We see the height here. We see a triangle. That's at a right angle because that's a height is an altitude, which is straight up. And well, how could we find it? Well, we could maybe use some trigonometry if we knew one more length here. We definitely don't know this length. That is not known. Hopefully it's in your mind that this piece right here is pretty clearly 7. And then this piece right here is then going to be pretty clearly 1 because they add to 8. And then we can easily see, oh, we have a side we're looking for, the height, which will unlock the entire problem. And then we know another side, which is a length 1. And we have an angle up here, and we can use some simple trigonometry. When we do that, we really have to think, just for a second, what is this angle that I'm marking solidly in purple right here? What would this angle be? Don't use 103, right? Because of course 103 is for the whole angle. So what is that purple angle? Well, I sincerely hope you realize that what we're going to do is subtract 90, because this angle right here is 90, and so the remaining original purple angle I was marking will just be the remainder when we take 103 minus 90, which is of course 13. So this angle right here is 13 degrees. Great. Now we can use our trigonometry to find the height and then finish the problem off. So when we use trigonometry, of course, the first thing we do is we label the sides super clearly. Let's do that in this nice blue color. Here's our angle. Our reference angle is the official name for it. Go straight across from the reference angle. Of course, that's the opposite as we've been learning, and this is the adjacent. We know that's the adjacent side, the height, because the hypotenuse is over here. The 13 degrees is not the hypotenuse, the 13 degrees is the angle. So let's finish this off. What's the height? Well, we're going to use opposite and adjacent because we have the length 1 and we're looking for the side h. Hypotenuse is not going to get used here, and opposite and adjacent is tangent. So we can say that the tangent of our angle, which is 13 degrees, will equal our ratio of opposite to adjacent, which is 1 over h. And now we look up the ratio for the tangent of 13 degrees, and we pull out our handy dandy calculator, and we punch in, make sure we're in degree mode, in Desmos, and we punch in tangent 13, 0.2308. All right, we could copy and paste this, we could do more things. I'll show it my way. So back to right here really quick, the tangent of 13 degrees is 0.2308 equals 1 over h. And then we could cross multiply by putting a 1 on the bottom to solve for h, or we can multiply both sides by h. I like to, even though it's a little unorthodox, I like to put a 1 on the bottom and cross multiply. So 1 times 1 makes 1. 0.2308 times h is 0.2308h. And we finally solve by dividing on both sides. When you divide by a decimal that's less than 1, the number on the top actually gets larger. Usually you think you divide, the number gets smaller, but this one is going to get larger. Let's calculate it. And so 1 divided by 0.230. I should put 9 because this 6 rounds. Whoops. 0.4. Oh, whoops. Here it is. Oh, I don't feel like redoing this video. Just bear with me. 1 divided by 0.2309 is 0.433. All right, there it is. Cool. That's the length. We just divided. That was our last step. Let's write it down. So the height is 4.3. Now with this height, we can take it and use that in our formula for the area of a trapezoid. And we'll finish it off right now. So let's see. Area is going to be 1/2. 7 plus 8 is 15. The height is 4.33. And we just calculate that. And let's see what we get. I'll remember to turn decimals on this time. Here we go. Let's clear this out. And what do we got? We got, I'm going to do 0.5 for 1/2 times 15 times 4.33 is 32.475. And that is the area of this trapezoid. I hope this helps you. Good luck.